Hey guys, how's it going? I'm gonna continue doing derivatives today. Um, and this is part of the exam review that I normally work on. If you're new, this is Lehigh Tutoring. My name's Martin. We just posted our channel trailer, which is kind of cool. And check it out. I'll have a link to it in the description box below. Please subscribe, support us. We have Instagram, Twitter, Patreon, so we definitely appreciate all the support that you guys do give us. So okay, 11a. These guys, we did product rule in the previous videos. Today we're going to do quotient rule, right? So we're going to do f of x equals x squared over x minus 1. Okay, now quotient rule, you've got the derivative of u over v. The derivative is basically v u prime minus u v prime, okay, over v squared. Okay, that's essentially the derivative. I should have written that over here. I think that would have been better over on the right side, right? So let's do that over here. Let's rewrite it. So again, it's going to be v u prime minus u v prime. Okay, do not get this confused, all right? You take the bottom and you place it at the top, then you multiply by the derivative of the top minus, and then the reverse, okay, over v squared. All right. So here's what I do when I'm answering these questions. I actually do these individually. Like I do the top derivatives first, bottom derivatives, and I just put it all into this formula, right, that I've given. So let's do that. So u equals x squared, v equals x minus 1. So u prime equals 2x, okay? V prime equals 1. So now we can just plug it into our formula that we've just written out. And let's do that now. So v is x minus 1, okay? V prime u prime, excuse me, is 2x minus x squared times 1. Very simple. All over x minus 1 squared. Okay. Now, if we expand these two guys, we get 2x squared minus 2x minus x squared. And so we end up getting x minus 1 squared on the bottom. Let's see, we get x squared minus 2x over x minus 1 squared, right? And we can factor out a factor of x on the top. Let's do that. And we gotta take away one factor there, and we're done. That's our derivative. That's our answer. Okay, so that's part A. I warn you though, like when you're doing these questions, you don't have to jump directly to the quotient rule, and I'll show you what I mean. So for example, look at part C, right? When you're doing part C, right, there's no need at all to jump to the quotient rule, right? I'm going to do part B. I'm not going to miss that, but I just want to demonstrate a point here. Now, this is a quotient of functions. I'm not going to say that it isn't, but I know that there's an identity. Sin x over cos x is tan of x. Okay, the derivative of tan x is secant squared x, sec squared x. That's perfectly fine as an answer for part C. Okay, perfectly fine. Now let's go back and do part B. Part B is so easy, so straightforward. And I recommend you do quotient rule and product rule in this way, like where you're splitting it up, right? It just makes it easier so that you're not, you don't have a headache, right? Okay, in this case, u is x squared minus 1, and v is a very similar form. It's the conjugate x squared plus 1. U prime is 2x, v prime is also 2x, right? That makes it a little easier. So I'm just going to jump into f prime. And what I'm going to get is I'm going to get x squared plus 1 times 2x minus x squared minus 1 times 2x. Okay. Over x squared plus 1 squared. All right? Now, I'm not going to do the expansion right away. I want you to notice something. This guy is going to perfectly cancel with this guy in the expansion. Okay, notice that, because they're both multiplied, they're both 2x times x squared, right? So they're going to kill each other. So what I'm going to do, instead of doing the expansion, I'm just going to do this. Okay? And the other guy will not cancel. Watch this. It's going to be 1 times 2x, that's 2x, plus 2x. They don't cancel. So I'm going to get 4x on the top and x squared plus 1 squared on the bottom, and I am done with that guy. Okay? And I'm also, let's see. Okay, I'm just going to erase this stuff. If you guys have any suggestions in terms of how to make the erasing much faster and more efficient, let me know. I tried like just doing a new page, and that kind of brings me to like a notepad. It's Zernal for Linux or Linux. Okay, in this case, u is sine x, v is e to the x. Now the derivative of e to the x is just e to the x. Remember that. The derivative of sine x is cos x. So let's do this derivative. F prime of x equals e to the x cos x minus e to the x sine x. Beautiful. Okay, all over e to the x squared. Now notice, I've got a factor of e to the x right here. I've got a factor of e to the x right there. And I've got a factor of e to the x on the bottom. 2 factors, actually. So why don't I do this? Why don't I factor out e to the x? Okay? And that provides me with an opportunity to cancel. So I'm going to cancel this with one of the factors on the bottom, and my final answer just sticks out like a sore thumb, right? Cos x minus sine x over e to the x. Done. All right, so that's that answer. Let's see. Next we've got root x over ln of x. No tricks, right? We just got to go right into it. In this case, u prime is going to be 1 over 2 root x. Remember that derivative. Okay, it really helps a lot. This guy is 1 over x, the derivative of ln x. So remember, this is u, okay, and this is v. Please do not forget that. And so let's run with it. So f prime of x is going to be ln x times 1 over 2 root x, all right, minus, let's see, root x times 1 over x. Okay. Now that actually helps out a lot, right? And you're going to see why. Now, we've got ln x here times, notice at the very top in the second term, right, x on the bottom can be rewritten as the root of x squared. Why that's important is because I can cancel a factor of root x. Okay, so I'm going to show you what I mean. So 1 over 2 root x minus 1 over root x. Okay, actually I should just show it to you just so you're not freaking out. 1 over root x squared, right? The square of root x is x, so there's nothing wrong with doing this. Now I can cancel, right? And I just get 1 over root x. So I'm just going to rewrite it as 1 over root x, and that makes my life a little easier because that provides me with an opportunity to factor out a 1 over root x in the bottom, in the top, excuse me, in the numerator. So I'm going to do that, 1 over root x. And just for fun, right? And I end up getting ln x over 2 minus 1 over ln x squared. That, I guess that's how I would put it as my final answer, but any variation to it would be fine, I think. You know, it should be okay. And if you don't see it if you're in a multiple choice situation, for example, and you don't see it, try to rearrange that answer so that you can get one of the answers that's provided in the multiple choice, right? Let's do this. So next, we are doing a similar sort of situation. We've got part f is ln x over sine x. So u, in this case, is, u prime is 1 over x, right? Because u is ln x, v is sine x. The derivative of sine x is? That's right, cos x. So the derivative, I like to have fun, sorry guys. The derivative is sine x times u prime, and that happens to be 1 over x, minus ln x times the derivative of sine x, which I have provided. It's cos x, yum, okay, yummy in my tummy. And then we get sine x squared, or sine squared x on the bottom. Yeah, so we're done. You could simplify this a little bit more if you'd like. You could factor out 1 over x on the top. So what would happen is you get 1 over x bracket sine x minus x ln x cos x, okay, over sine squared x. And what you do in this situation is you would just literally tack on that x in the bottom, and it's perfectly fine. Okay, and so you could leave that as a final answer, and it should be absolutely fine. So that is that essentially in terms of quotient rule. So this stuff was basically quotient rule, right? Quotient rule fun. Okay. Next, we will do a little bit of chain rule. All right. So we're going to do chain rule basically for 12, 13, and 14, and then we're going to do like velocity, acceleration, first and second derivatives. But I'm just going to end this video at chain rule, and then yeah, and then another video I guess would be on like first and second derivatives, because when you have second derivatives, you're talking about like concavity and all this stuff, and points of inflection, which is I always love points of inflection. I know some students are probably like, oh gosh, this guy won't shut up, but I actually really enjoyed it, and hopefully you'll enjoy it too. One thing that I won't do in these videos, I think, is curve sketching, just because it's really tedious to do. So if you don't mind that, then you're fine, I guess, or you might be fine otherwise. Okay, so we've got 12a. Okay, so it's basically giving me an instruction, right? So to get my final answer, I take this derivative for y in terms of u, so I differentiate this, and I multiply by the derivative of u with respect to x. So I'm just going to run through each of them, right, individually. There's only two examples. So dy du, okay, I'm not doing my final answer, right? This is Leibniz notation. This is y prime. I'm not going to do that yet. I'm going to do dy du. So the derivative of y with respect to u is just going to be 5u to the 4, right? That's power rule. No problem. Du to dx is equal to 2, right? That's the derivative of 2x minus 1. To get my final answer, y prime, just multiply them, right? 5u to the 4 times 2, right? So 10u to the 4. But what's u? U is 2x minus 1. So all I have to do is change that to 2x minus 1 all to the 4, and I'm done. Finito. Part B. Let's see, dy du. Look at how many I'm going to tell you, root x, it's a really important derivative to just remember off heart, right? Instead of having to change it to like power rule and then doing the differentiation, then putting it on the bottom, changing it in terms of root x. Okay, so dy du in this case is 1 over 2 root u. Very simple. Du dx, okay, is equal to 2x. Multiply them together, and we get y prime, or dy dx. 1 over 2 root u times 2x. 2's will cancel, right? 2's will cancel, and we get x over root u. But remember, u in this case is x squared plus 1. So we get x over root of x squared plus 1. Done. Finito. Okay, now we're going to do more chain rule. It's going to be just 3 quick examples, and they don't give us this rule that we just did. We have to actually invent. So notice in this question, they gave us what u was in terms of x. We have to kind of invent that ourselves. And we might even have to do it twice, because I'm looking at part B for 13, and it looks like we have to do it twice. We have to do like 2 substitutions. Don't worry, don't panic, don't freak out. It will be okay. Okay, so we've got 13a. Okay. Yeah, we're gonna have to do actually 2 sets here. Y equals let's see, w squared, right? So this whole thing, right, I'm calling w. All right, but I'm going to make another change. What I'm going to do is I'm going to say also u equals x squared minus 1, because that's the nasty part as well, right? That is nasty. So I'm going to say u equals x squared minus 1. So that means that w I've rewritten as u cubed plus x squared. All right. So let's see if this works. So to do the derivative then, I need dy dx. That's my answer in the end. That's y prime. It's got to be dy dw, okay, times dw du. This doesn't look right. Well, no, okay, because I haven't rewritten this properly. Okay, so if u is x squared minus 1, this means that, notice, w doesn't just have u, it has x as well, u and x. That's bad. If you're going to put a letter, right, if you're going to substitute for a letter, make sure that there's no like two-letter situations, right? You need it all in terms of u. So, okay, if u is equal to x squared minus 1, no problem. That means that x squared equals u plus 1, right? So I could replace this thing by u plus 1. Okay, you see how we did that? Go back and rewind just in case. And then to finish it off, I get du dx. Okay, now I think we're good. So, okay, dy dw, that's the derivative of like x squared, that's power rule. Okay, so that's 2w times dw du. That is 3u squared plus 1, right? That's like x cubed plus x plus 1, that's the derivative. Okay, times 2x. All right, now I just got to substitute everything back in, all right, in terms of x. So it's going to be, let's see, I'm going to, these coefficients, this one and this one will combine for 4, right, a value of 4. W is this thing, right, this whole thing, all right? So w is, I'm going to put a big bracket, okay, w is x squared minus 1 cubed plus x squared, right? Notice I'm not including this, right, that exponent of 2 on the outside, it's what's inside, right? Times 3, and u is x squared minus 1, that's squared, right? Okay, so this is nasty, all right, plus 1, and then it's just x at the end, right? So I'm just going to take that x and place it right here, and I think we are done, okay? That is, wow, like that's a mouthful, right? That's a lot. So, okay, so there's that. All right, so memorize how we're doing this, right? You got to put letters in terms of letters and then just go ham, okay? And you will sometimes need like 2 substitutions the way I'm doing it. The reason why I do it this way instead of like direct differentiation, which isn't too bad, it's just that when you see like I remember having exams, okay, and when I saw like problems, like 30 problems like that, I would start to like hurl after like, you know, there would be too many to deal with. Okay, y equals, let's see, y equals 1 minus x squared over 1 minus x cubed. So I said maybe you need 2 substitutions. I don't actually think you do when I look at this. Let's see, there's some magic that I can do here. On the top you get a difference of squares, don't you? That's right, you do. So you can rewrite the top, right? This is 1 squared minus x squared. That can be written as 1 plus x times 1 minus x, okay? And that whole thing is squared, right? That's this guy, okay? Over 1 minus x cubed. And the reason why we want to do that is that we can cancel 2 factors of 1 minus x with 2 factors of 1 minus x. So we end up finishing it up with, or simplifying it, excuse me, with 1 plus x all squared on the top and 1 minus x on the bottom. Okay, now it's easy. So just set u equal to 1 plus x, that's the nastiest part, that means that, let's see, that means that x equals u minus 1, right? So that means that 1 minus x equals, and notice I'm trying to substitute for that, then 1 minus x equals, I don't know if this is really helping too much. Let's see. Maybe we could just literally do... No, it wants us to do chain rule. Okay. That means that 1 minus x equals negative x. So it's going to be 2 minus u, I think, right? Because if you multiply by negative 1, okay, you get that, and then add 1. Okay, yeah. So this is good. So it's 2 minus u. All right. So let's transform this sucker, right? So we're going to get u squared over 2 minus u, and we're going to do a differentiation of this, all right? So we need dy dx, right? So that implies a dy du, okay, times du dx. Du dx is simple, right? Du dx, if u equals 1 plus x, du dx is just 1, right? It's just 1 because it's the derivative of x. So this guy is 1, right? So really our answer is just this and then substituting u for x, right? So I need this derivative, right? And it's a product rule. And I notice I really screwed myself here because I set the letter to be u, right? And the quotient rule deals with u and v, so it's kind of confusing. Anyway, so let's do this. Dy du. The bottom goes to the top, right? That's v. Then u prime is the derivative of the top, so that's 2u minus u squared times negative 1, because that's the derivative of negative u, over 2 minus u all squared. So let's see. We can simplify, I hope, and we end up getting 2 minus 2u squared plus u squared over 2 minus u all squared. All right, great. Look at this. Look at this. So we end up getting on the top, negative 2 apples plus 1 apple is negative 1 apple, right? So this is going to become 2 minus u squared, okay? And that translates to, this is not a difference of squares, so we can't do that. Okay, so this is going to be 2 minus 1 plus x all squared over, and then remember 2 minus u turned out to be just 1 minus x, so it's 1 minus x all squared. Man, that was a mouthful. I hope that is okay. That is dy dx in this example. If I made a mistake, let me know in the comments section, and I'll, make a new video and comment, change it, and, whatnot, but I think it should be okay. That was tough, right? Doing chain rule sometimes sucks. Okay, so I hope you can't hear the erasing. Sometimes, like when I'm erasing, I can actually hear the audio of the erasing. It's weird, but hopefully you can't actually hear that in this video. So we got y equals square root of x plus root x. Cool. So let u equals x plus root x. Okay, now I just did a substitution. So then y equals square root of u, right? So dy dx, which is what I want to find, that's y prime, that's dy du, okay, times du dx, all right? Now, du dx, whoops, equals 1 plus 1 over 2 root x. Easy. Dy du is 1 over 2 root u, right? So we put it all together. Oh, man. Okay, put it all together. U is this. So I end up getting 1 over 2 root of x plus root x. Oh, man. Can you imagine like doing straight up derivatives without chain rule? It's kind of like annoying, right? Get a headache. And I think I'm going to just go ahead and do the number 14 and just like, finish it up. And then I'm going to leave first and second derivatives for next time, and like velocity and, acceleration functions for next time. So let's do this. 14a. Okay. U equals 1 plus that nastiness inside the power, right? That base. So dy dx equals the derivative of u to the 10. That's 10u to the 9 times the derivative of this guy, 1 plus 2x. All right. So I plug in what u was, and I get 1 plus x squared all to the 9 times 1 plus 2x, and you're done. All right, that's A. Okay. Let's see. Now, my substitution will be x squared minus 2x. All right. So dy dx equals 1 over 2 root u times 2x minus 2. All right. And so it's going to be, I can kill a factor of 2. Watch this. Boom, boom. So x minus 1 and boom, right? So this becomes x minus 1 over root u, okay? And u is that, so it's x squared minus 2x. There, x minus 1. You can rationalize this by like multiplying the top and bottom by root of this to rationalize it, but I just leave it, right? And that's that. That's part B. Let's see. In this case, part C. This is part C now, right? Sine of root x, so easy. Root x is u. So dy dx equals the sine of u. That's the derivative of that is cosine of u times 1 over 2 root x. Look at how many times I use that derivative, right? It makes life so easy. And so that's my derivative function. Easy, easy, easy. Okay, and then now I make the inside of the square root my u, so cos x. Okay, so it's going to be 1 over 2 root u times negative sine x. Okay, so this becomes negative sine x over 2 root cos x. Done. Done. Okay. Next, using this systematic approach makes it so easy. Life is so good. Okay, so ln of u, right? So 1 over u, that's the derivative, times 1 over 2 root x. Okay, so I get 1 over root x times 2 root x, right? Did I do that right? Yes, I did. Okay, and so I get 1 over 2x. Done, right? Easy peasy. Okay. Next mundo. Root of x plus e to the x. So x plus e to the x is our magic substitution. And so it would be 1 over 2 root u times 1 plus e to the x. Substitute, and we get 1 over, actually I'm just going to group it together, 1 plus e to the x, 2 root of x plus e to the x, and we're done, right? That's that. So that's 14. I just did 6 questions just like that using my chain rule, and we're done. Next up, it's going to be first and second derivatives, velocity, acceleration, critical values, critical points, right, where the derivative is 0, intervals of increase and decrease, which are so fun, local extrema, first derivative test, absolute extrema, so they give like intervals. Those are fun. Intervals of concavity, which deals with like, if like the double derivative is like greater than 0, it's concave up. If the double derivative is less than 0, it's concave down, stuff like that. Points of inflection, right? Graphically, points of inflection are like when you have a change between concavity, right? So this point would be a point of inflection where it's concave up over here, concave down over here, right? So it's where the second derivative is equal to 0. Okay, that would be a point of inflection. So yeah, and then curve sketching. I think I'm gonna skip this stuff because it's tedious. And then my last video on calculus in general, given this like package, is going to be on like questions on optimization, which are always fun. And then this is again what I've been waiting for, to start on vectors, but I want to finish through calculus. And the reason why there's vectors in this course is that, once upon a time when I was taking this course in high school, and I'm based in Ontario, right? So we had just basic calculus. There was a separate course for vectors, I believe. It was called discrete algebra and geometry, and there was vectors in that course. What they did after 2007 was that they merged vectors with calculus, and they called it calculus and vectors. And so that's what I'm basically teaching you guys. If you don't have like vectors, if you don't have to worry about vectors at all, I can understand that they can cause people to barf, right? Like it's crazy. If you don't have vectors at all, if you're not a physics buff, if you don't need them, just we'll end at like optimization, and then you're done. Right? You're done with calc. This is basically an intro to calc grade 12. I want to do upper years. I want to do like university level too. But yeah, we would love your support. Like, comment, subscribe, share our videos. We really appreciate your support. We love you guys. Lehigh for the win. And share this with your friends. Like, if anyone is struggling, honestly, guys, send us your assignments, and so that we can help you, and we can post a specific video and send it to you. All you have to do is email the assignment or take a picture of it, like email it in PDF form, take a picture of it, send it to contact@lehightutoring.com, or send it over Instagram. Like I've had students like honestly send me their assignments via like a little picture that they took on using their camera phone on Instagram, and then I just literally post a video me answering those questions one by one. It's so much fun. So let us know. We love to support you guys, and we just appreciate support back. Again, like, comment, subscribe, and share. Have a good one, and thanks so much.